Hi everyone, my name is Larry, also known as the Old Gazer, and you're watching the Old Gazer YouTube channel, which is all about amateur astronomy, and specifically it is geared towards beginning or inexperienced amateur astronomers with the goal of providing you with some useful information that hopefully will help you work your way into this great hobby. So welcome aboard, and let's just get started. This is the third of a series of videos on taking pictures through a telescope using a DSLR camera. Now, if you haven't watched parts 1 and 2, I would suggest you might want to do that. They're not essential, not an essential prerequisite, but they will help to put this in perspective, and you might get a little bit more out of this video if you were so inclined to go back and watch those two first. In the first video, we talked about why you might want to consider learning how to take pictures through a telescope using a camera. We also demonstrated how to attach a DSLR camera to a telescope using a T-adapter and a T-ring. Then in the second video, we talked about some important settings on a DSLR camera within the context of taking pictures through a telescope. We talked, for example, about the requirement to set the camera in manual mode. We talked about the likelihood that you're going to have to use a high ISO or ISO setting to brighten up your image. We talked about the need to use your live view screen on the camera to monitor and control everything. We talked about the need to have a remote shutter control so that you won't have to touch your camera when you're actually in process of taking pictures. So we talked about all of that. Today in this third video, we want to talk about shutter speed or exposure time. How long can you hold your shutter open when you're taking a picture of objects in the night sky, and why is it important to keep that shutter open as long as you possibly can? Well, here's why. These objects that we're trying to take pictures of in the night sky, these deep sky objects, are very, very dim, very faint objects. It's very difficult to see them. As a matter of fact, in most cases, if you have significant light pollution in the area where you do your viewing, and if you have just an amateur telescope, you're not going to be able to see very much at all if you just try to view these deep sky objects. You might see a gray smudge or a gray wispy area in the field of view. It just won't be able to see very much, and that's a source of great frustration and disappointment to many astronomers when they come to realize that, hey, once we've seen the moon and the planets and the Orion Nebula and maybe the Pleiades, we can't really see much of anything else. I had a comment made this week based on last week's video where we talked about this issue, and this was a very perplexed and frustrated viewer who had invested about $3,000 in a telescope only to find out that they can't really see anything except little gray areas, if that. And they were very discouraged by that and trying to come to grips with that in order to see any of these objects. You're pretty much going to have to learn how to take long exposure photographs of these areas, now, of these objects. Now, when you take a long exposure photograph, you're collecting a lot of light. And the longer that the shutter remains open, the more light will be collected. So you're gathering light, you're gathering signal that will enable you to get a good image of something that you otherwise wouldn't be able to see very well, if at all, if you're just looking through the eyepiece of a telescope. So that's the reason why you really have to learn how to do this. And when it comes to shutter speed or exposure, you want to have that shutter open as long as you possibly can in order to gather as much signal as you can to make a better picture with more detail. Okay? Now, that's easier said than done. The big challenge facing us when we try to take pictures of objects in the night sky through a telescope is that we are trying to take long exposure photographs of moving objects. Which is, if you think about that a little bit, you can see the difficulty involved there. Now, by the way, I know as well as you do that these objects in the sky are not actually moving. It's the rotation of the Earth that is giving apparent motion to these objects in the night sky. But, you know, for all practical purposes, we are trying to take photographs of moving objects. And as we've just said, that's a very difficult thing to do. So how do you do that? You need to take exposures as long as possible to gather as much signal or light from the object as possible. But at the same time, these objects are moving. And so what happens is that over time you will start to see star trails in your photographs, blurry images, because these images will have moved while you're trying to take these long exposure photographs. So that's the challenge facing people who want to take pictures through a telescope of night sky objects. You're trying to take long exposures of moving objects. Now, what's the answer to that? Well, what you do basically is you use a device known as a tracking mount or a star tracker, which has a computer in it and which has gears and motors in it, and which has the capability of moving your telescope in a direction opposite to the rotation of the Earth and at the same rate as the rotation of the Earth, which of course results in the object appearing to stand still instead of move across the field of view. And then you can take long exposures. You're no longer taking pictures of a moving object. You're taking pictures of an object that has been made to stand still because of the use of this tracking device. So that's the answer to it. You get a tracking mount that is capable of finding and tracking objects across the sky. Freezing them in place is one way to put it, so that you can then take long exposures. All right, so that's what we're going to talk about today. How to determine how long your exposures can be given different types of mounts on which you might have your telescope mounted. And we're going to start out by talking about what to do if you don't have a computerized, motorized tracking mount. What if you just have a manual mount, whether it's an alt-azimuth mount, maybe a Dobsonian mount, or even an equatorial mount that has no computerization, no motorized tracking capability? What can you do if you've only got a manual mount which requires you to move the telescope by hand in order to follow the path of objects across the sky as they begin to pass out of your field of view? What can you do if you don't have any means of counteracting the rotation of the Earth? Well, all is not lost. You can actually take long exposure photographs using a manual mount. But of course, the reality is that you're going to be taking short, long exposures. I realize, what's the word for that? Is that an oxymoron, or is that a logical fallacy? Or, you know, I don't know what the word for that is. But what does it mean when you say short, long exposures? Well, of course, I'm very simply meaning that you're only going to be able to take 1 or 2 second exposures, more than likely, if you have a manual mount with no tracking capability. After about 1 or 2 seconds, this object will have moved enough within the field of view of your telescope so that star trails and blurring of the image will start to be a problem. Now, some people have, I've read accounts of people being able to expose longer than 1 or 2 seconds, pardon me. But my own personal experience, and by the way, let me pause here for just a minute. There are numerous places where you can go and read about exposure time in great detail, and they will give you formulas by which you can calculate the maximum exposure time that you should reasonably expect to take given different equipment and different conditions and that kind of thing. But we could really get bogged down in that, and that's not the intent of this video. So as we go through here and discuss exposure times, I'm just going to give you the benefit of my own personal experience at having done this with different kinds of mounts over a long number of years. You might have a little bit different experience than me, but I'm going to give you the benefit of what I have found to be true, given my camera and my equipment and my experience at trying to take these photographs of objects in the night sky. My experience has been that you're only going to be able to take 1 or 2 second exposures if you have a manual mount. After about 2 seconds, you cross that threshold and you start to get star trailing and blurred images. Now, again, I've heard of people who say that they've been able to get 5 second exposures or maybe even longer. I have never been able to do that. I'm just being honest with you. If you have been able to, that's wonderful. Maybe you can share your experience in the comments section of the video. The best, the absolute best that I've ever been able to do was, I think about a year ago, more or less, when I was out trying to take some pictures of the Orion Nebula using a small refracting telescope on a purely manual mount. I was able to take 2.5 second exposures without getting any significant star trailing or blurring of the image on that night. And that's the best I've ever been able to do using a manual mount. Most of the time, I can only manage 1 or 2 seconds, and I just don't try to go beyond that because my experience has been that for me, in my circumstances with my equipment, longer exposures are simply not feasible with a manual mount. Now, you might say, well, 1 or 2 seconds? That's not going to be long enough to gather very much light from these extremely dim deep sky objects. What good does that do? Well, first of all, a 1 or 2 second exposure is certainly a lot better than a 1/30th of a second or 1/25th of a second. You know, my definition of a long exposure photograph is one that is long enough that you can't hold the camera in your hand while you're taking the picture because of the shake, the vibration, the movement causing a blurred image. If an exposure time is so great that you can't hold it in your hands, I consider that to be a long exposure, and 1 or 2 seconds certainly falls in that category. Now, you still can get much better images by using a process or a technology, or call it what you will, called image integration or image stacking. Now, we're going to, the 4th video and hopefully the final video in this series, which will be coming up next, is going to be all about a tutorial on how to accomplish this image integration or image stacking technique in order to produce much better images than you otherwise might be able to take. Here, I'll only say this. Suppose you take not just 1 2-second exposure of, say, the Orion Nebula. Suppose you take 60 2-second exposures of the Orion Nebula, one right after the other, right after the other, and so that at the end you wind up with 60 2-second pictures of the Orion Nebula. There is a process using software, some of which is free to download, which will take those 60 pictures and merge them into a single stacked image, which will be a much higher quality than any of those individual 2-second images could ever be. It eliminates noise, it adds signal, it adds each picture will bring a little bit more detail. It's quite a process, and we're going to talk about it in detail in the next video. But if you take 60 2-second exposures of the Orion Nebula using a manual mount, and you then stack or integrate those 60 pictures into one composite image that's far better than any of the individual images, you can then pull that stacked image into a photo editor and adjust the brightness and the contrast and the saturation and the exposure and all of that, and come up with hopefully a pretty decent image of the Orion Nebula. Now, here's kind of the way it is. This is not strictly true, but it's close. If you take 60 2-second pictures of something, that's going to give you a total exposure time of 60 times 2, or 120 seconds, 2 minutes. So taking 60 2-second photographs and merging them together is sort of the same thing as taking 1 2-minute exposure. So maybe you can get the idea from that you can take, for all practical purposes, much longer exposures than just 2 seconds, by taking multiple exposures and stacking them together. So that's what you're going to want to do if you have a manual mount. Take a lot of exposures, short exposures, one after the other, transfer those images to your computer, run them through this stacking software, take the output from that into a photo editor, and edit a few things, and you've got hopefully a very decent picture as it comes out that end of the process. Again, we're going to do a tutorial on that process in the next video. So that's what you do if you have a manual mount. Now, please don't be intimidated by all of this. This image integration or image stacking process is really not that difficult. It's like just about everything else associated with amateur astronomy. It takes patience and it takes a lot of practice to get good at it. But once you kind of get that process down, it's not that difficult. It's actually a very fun thing to do, at least to me it is. Just kind of see this image come to life before your very eyes as you go through the various stages of this image integration process. And it's not that hard to do. Don't be turned off by that. I wanted to be a purely visual astronomer. That's what I would like to be if it were possible. I would like to just go out and look at things through the eyepiece of my telescope. But with light pollution and with the limited size of amateur telescopes and so forth, you just can't see very many of the deep sky objects doing that. So this is a good alternative for dealing with that. And it's not intimidating, it's not difficult at all. It just takes a little practice and a little familiarity, and you can do it. You can turn out some decent photographs with 1 or 2 second exposures. Now, I'm going to stop here for just a moment and show you an illustration of some pictures that I took using a manual mount that'll give you an idea of how this works and what to expect, and then we'll come back after that. All right, what you see on the screen is a view of the Orion Nebula. I believe I took this about somewhere around a year ago, maybe February, early March of 2021. I went out with a 70 millimeter refracting telescope and a manual mount to take some pictures of the Orion Nebula, and this picture is a pretty good, pretty reasonable depiction of what it looked like just through the eyepiece of the telescope. As you can see, not a whole lot to see there. The next picture that you're going to see is what it looked like through the telescope with the camera attached. And that is a 2.5 second exposure. As you can see, just 2.5 seconds gets you a lot more detail, a little bit of color, looks much better than just the initial view through the eyepiece. Now what I did was I took, if memory recalls, about 55 2.5 second photos of the Orion Nebula, and I stacked those together using a program known as Deep Sky Stacker. I integrated those together and pulled that stacked or integrated photo then into a photo editor called Affinity Photo. And what I came up with after I had done some editing of brightness and contrast and exposure and saturation and color balance and all of those kinds of things, here is the final product. And not too bad. So I showed you this just to let you know that it's not too bad to go from this 2.5 second photograph of the Orion Nebula to something like that if you're willing to learn how to do the image immigration or image stacking technique. You can see that that's a fairly decent picture of the Orion Nebula obtained from integrating or stacking about 55 2.5 second exposures using a small refracting telescope and a purely manual mount. Okay, we've covered how to take short, long exposures using a manual mount. Let's move on now to the tracking mounts, the computerized, motorized tracking mounts with the gears that are able to track objects across the sky for you, hold them in place while you take pictures. Obviously, you're going to be able to take much longer exposures if you have that kind of mount. Now, there's two kinds of mounts basically that I want to talk about here. One of them is an alt-azimuth tracking mount. Now, that's the one like I have here. This is an alt-azimuth tracking mount. This mount is able to find objects for you in the night sky, and then it's able to follow or track those objects across the sky once it's found them so that you can take longer exposure photographs. However, an alt-azimuth mount has some limitations, and that's going to affect the maximum exposure time that you can expect. And here's the thing. If you watch my video on mounts, you will of course realize that alt-azimuth mounts can only account for 2 of the 3 components of movements as an object moves across the sky. It can account for the vertical or altitude component, the horizontal or azimuth component of motion, and it does a very good job of tracking that motion across the sky. What an alt-azimuth mount cannot account for, however, is field rotation. That object is not only moving across and up the sky, it's also rotating as it does so, and an alt-azimuth mount is not able to account for that field rotation, and therefore there will come a time at which you will start to get star trails in your image, even with an alt-azimuth tracking mount. So, how long can you expose with an alt-azimuth tracking mount before you reach that threshold at which star trails and blurred images become an issue? Well, again, I'm going to give you the benefit of my own experience. I've taken many photographs using this alt-azimuth tracking mount, and I have learned that sometimes you can take up to about 30 seconds or so worth of exposure using an alt-azimuth tracking mount, but I have found that that very rarely is the case. Typically, if you want to be on the safe side and you don't want to waste a lot of time taking pictures that are going to be blurred or have star trails in them, I have found that you can usually expect to get reasonably about a 10 to 15 second exposure using an alt-azimuth tracking mount. Sometimes more than that if you've done a really good job of leveling your mount and aligning it, and if the fates of astronomy are with you or on your side, you might be able to get more than that. But the best thing to do is to kind of figure on 10 or 15 second exposures before you reach that threshold beyond which you don't want to expose any longer. Now, 10 or 12 seconds, of course, is a lot better than 1 or 2 seconds. You can collect a lot more signal and get a better image doing that. However, it's still not a great deal of time. These deep sky objects are very dim, very hard to collect enough light to give you a decent image. I mean, you can get an image, but it's probably one you're not going to be very pleased with. So you're going to want to do the same thing with an alt-azimuth tracking mount as you did with a manual mount. You're going to want to take many 10 or 15 second exposures using this alt-azimuth tracking mount, and then using that same process, integrate or stack those images together into a single stacked image, which you then edit in a photo editing program in what's called post-processing. So you just won't have to take as many pictures. Let's say that you're going to take 10-second exposures of the Orion Nebula using this alt-azimuth tracking mount. How many is it going to take to get 2 minutes worth of exposure? Well, at 10 seconds, you're going to need 12 exposures to get 2 minutes worth of integration time, which is the same as you would have gotten if you had taken 60 2-second photographs using a manual mount. So, it takes the same amount of time, but far fewer photographs if you can get longer exposures. And I've seen, technically, I mean, you might think that 62-second exposures, that 2 minutes of exposure, would give you the same quality result as 12 10-second exposures on this this tracking mount. That's not really the case. The longer you can expose, the better. You will get higher quality photographs with longer exposures, even if the integration time is the same. 2 minutes integration time on a manual mount is not going to yield quite as good an image as a 2-minute integration time on an alt-azimuth mount. That's just the way it works, but the difference won't be that great. So anyway, alt-azimuth mount, you should count on perhaps 10 or 15 seconds exposure time, more if you're lucky and have done a great job aligning your telescope. And you'll want to use image integration to take numerous 10 or 15 second exposures and integrate or stack those together to provide a final image that you would then edit in post-processing. And that's what you can expect as an exposure time with an alt-azimuth tracking mount. And again, I want to pause right here and I'll give you an illustration of what I've done with taking some photographs using this alt-azimuth tracking mount, and then we'll come back and finish. This is what I first saw when I looked through my telescope at M13, globular star cluster in the constellation Hercules, when I went out this past summer to photograph it. And that's pretty typical as to what a deep sky object looks like, through the eyepiece of a telescope. I was using my 8-inch Schmidt-Cassegrainian telescope with, I think, a 24 millimeter eyepiece in it. And, that's what I saw. And that's the frustration that goes along with trying to view deep sky objects just through an eyepiece. Now, just a gray smudge. Now, depending on what device you're viewing this video on, you may not be able to see anything at all there except just a black screen, but you might be able to make it out. Right in here is M13, the globular star cluster in Hercules, approximately as I saw it just through the eyepiece of that telescope on that night. This second picture represents what it looked like through the telescope. That's one 15-second exposure taken at ISO 3200 of the M13 star cluster. As you can see the stars are starting to be resolved here, getting a little more detail, a little color, a little bit brighter image, but that is just one exposure of 15 seconds. Now, the next picture you're going to see is the integrated or stacked image. That's, if memory serves, I took somewhere between 70 and 80 15-second photos that night of M13, and this is what those 70 or 80 15-second exposures look like after they've been integrated or stacked together in the stacking software. Now that might not look like much, but there's a lot of detail hidden in there ready to be brought out in a photo editor. There's not much noise in that picture, and there's just a lot of things there that you can bring out in a photo editing program, which you can see in this final photograph, which is the final edited version of M13. Very bright in the center, as it should be. A lot of stars resolved. Not a bad picture. Taken again by merging together 70 or 80 15-second exposures of M13 through my telescope, and so that again is an illustration of what you can do with this photo stacking or photo integration technique, and this gives you an idea of the kind of thing that might be possible with an alt-az tracking mount, where you can take somewhere in the neighborhood of 10 to 15 second exposures pretty consistently. So you can go from this, just looking at it through the telescope, to that, if you're willing to learn how to take some photographs through your telescope, and if you're willing to learn a little bit about how to manage those photographs through the stacking process into a final product such as this. So just another illustration of what might be possible if you're not afraid to jump in there and start learning how to take some pictures through your telescope. Okay, we've talked about expecting 1 to 2 second exposures if you're using a manual mount, 10 to 15 second exposures if you're using an alt-azimuth tracking mount. The only remaining mount is, of course, a motorized or an equatorial tracking mount. Pardon me, an equatorial tracking mount. This is a mount that can account for all three of the components of apparent motion of an object through the sky. It can track it across, it can track it up and down, and it can also track the field rotation. So obviously you can infer from that, and correctly so, you can take much longer exposures with an equatorial tracking mount than with other kinds of mounts. Depending upon how good a job you've done in polar aligning that mount, which is a subject for another time, and depending upon various other factors, you might be able to take 1 minute, 2 minute, 3 minute, or even longer exposures, because that object is going to be stationary. For an all practice, as you're taking those pictures, it's going to be frozen thanks to the counteracting actions of your tracking mount. So you can take very long exposures, and that's going to give you much better results overall than any of the other mounts will yield. You can take 3-minute exposures, and you can take as many of them as you want and stack those together. And if you get enough integration time, you can produce some really spectacular photographs doing that. Now, that does take some money to get one of these equatorial tracking mounts, and if you want to get even more precise, you can use something called auto guiding, which is going to add to the expense of your system. But that's the way to get the longest exposures, anywhere from a few seconds all the way up to 2, 3, 4, 5 minutes, maybe even longer, depending upon the precision of your system. And that's what you're going to get there. So I don't have an equatorial tracking mount. I've never done that. Probably won't have one. I'm satisfied with taking my 10 or 15 second exposures and using image stacking or integration to produce a final product. I just don't want to get involved with the time and the expense associated with taking extremely long exposures using equatorial tracking mounts. By all means, go that route if you want to. You'll get the best results doing that. If you have the money and the time and the inclination, you certainly might want to check that out. There are numerous YouTube channels that are dedicated to long exposure astrophotography, some of them excellent. You might want to check those out and use those for guidance, and a lot of tutorials that you can view also to do that. So I think that probably about covers the subject. If you have a manual mount, you'll want to take 1 or 2 second exposures, take a lot of 1 or 2 second exposures, and then integrate or stack those together. If you've got an alt-azimuth tracking mount, figure on about 10 to 15 seconds exposure. You can experiment and see if you can get a little bit longer, but you can probably count on usually 10 or 15 seconds. And then you'll take several pictures that way and stack those together. If you've got an equatorial tracking mount, you can take very long exposures of up to several minutes. And so that tells you what exposure times you can expect, what exposure times you should expect to reasonably use depending upon what kind of mount that you have. Okay? I hope this has been helpful. I hope that none of you will be intimidated by all of this. This integration technique or this image stacking technique is not rocket science. It shouldn't be intimidating. It's not that difficult to do. It can be done with free software, which is pretty simple to use and which works very well. And we're going to, again, show you a tutorial about how to do all of that in the next video. So we're going to wrap this one up right here. Hope this has been helpful. Thank you so much, as usual, for watching. And once again, let me just close, as always, by very sincerely wishing for you clear skies and good viewing.